The next two array methods that we're going to learn are the flat and flatMap methods. And thankfully, these are very easy to understand. So let's go. So let's say that we have an array with some arrays in it. So essentially a nested array. So let's say 1, 2, 3, and then another array here, 4, 5, 6, and then even some values like this. So this is perfectly normal. But what if we wanted to take all these elements in the subarray and put all of these together in just one big array, which contains all the numbers here from 1 to 8? Well, that's pretty simple using the new flat method. And they say new because flat and also flatMap were introduced in ES 2019. So they are pretty recent, and one more time, they will then not work in super old browsers. And one more time, they will therefore not work in super old browsers. Okay, and actually that's it for the flat method. So no callback function, just like this. And we get indeed our full array from 1 to 8. So this removed the nested arrays and flattened the array, which is why the method is called flat. So very nice, very simple, and no callback function this time. Okay, but now let's say that we have an array which is even deeper nested. So let's call it R deep. And so this one right now has only like one level of nesting. But let's say that these two here are in their own array still. And maybe these two here as well. So now we have an array inside an array inside an array. So let's see what happens when we flat this one. And we got the same result, but that's because I made this mistake. So we need to flatten R deep. And so now you see that we get this result, which still contains the two inner arrays. All right. So this means that the flat method only goes one level deep when flattening the array. So this 3 here was inside the first level of nesting, and so therefore it was taken out and is now in the main array, but then we still have this nested array in there. So we can fortunately fix that by using the def argument. So right now, basically flat is running with the 1 here as the def. And so if we run it with 1, which is the default, then we get this. But we can go 2 levels deep. And so now we get the same result as before. And that's because it now goes even into the second level of nesting and also takes the element out of that array. All right? So that's how flat works, but this example is not really that useful. And so let's go back to the bank accounts. So let's say that the bank itself wants to calculate the overall balance of all the movements of all the accounts. So how would we go about solving this problem? Well, first of all, we have all these movements stored in arrays. And these arrays are inside the objects in the accounts array, right? So in this array that we have been using, so accounts, so that's the one. So this is where we have our movements. And so the first thing to do is to take them out of here and put them all into one array. So how would we do that? Well, let's create a variable here called account movements. And so we could do accounts like this. And then what we want to create is a new array, but with the same length, which only contains these movements array. So that's what I was just saying, right? And so for that, we can use the map method. So in each account, take the account dot movements and so return that value into the new array. All right. And so now we have this array, which then in turn contains the arrays of all the movements. And so you see that now we actually have a nested structure here. So an array which contains other arrays. And so probably you can see where I'm going with this, because now I want an array which simply contains all of these values just in one array. So let's call this one all movements. And so it's going to be account movements dot flat, right? And we have only one level of nesting, and so there's not even a need for any parameter here, so for any argument. So now we get this nice array of the length 29 with all of these movements. And now all we have to do is to add them all together, which is pretty easy at this point, right? So let's call this one overall balance is equal to all movements dot reduce. And here we get the accumulator and the current movement. And we return accumulator plus movement, and we start with 0. So I'm doing this all very fast here because I already explained all of this multiple times at this point, right? And so here we get the final result of adding up all of these values that were originally, as we started, in the separate movements arrays that were in turn inside of the account objects, right? And of course we can make this here a lot more beautiful. So instead of doing all of this separately, as you already know, we can use chaining. So we start with this here. So building a new array out of the array of account objects. Then we flat that result, and then we add it all together. So like this. And then we log it all to the console. And this is then unnecessary. And actually I will just delete all of it. Give it a save. And here we get the exact same result. Now it turns out that using a map first and then flattening the result is a pretty common operation. So that's exactly what we have here. So first we map and then we flat that result. So that's exactly what we have here. And so to solve this, there is another method that was also introduced at the same time, which is flatMap. And so flatMap essentially combines a map and a flat method into just one method, which is better for performance. All right. So let's do this one here again, but this time with flatMap. So actually we can just copy it, and here I'm going to call it just a 2. And so here we will now use flatMap instead. And since flatMap also does mapping, it needs to receive exactly the same callback as a map method. Okay, so this is essentially a map method. All it does is, in the end, it then flattens the result. And so you see here the result is the same. Now just notice that flatMap here only goes one level deep, and we cannot change it. So if you do need to go deeper than just one level, you still need to use the flat method. So anyway, keep these two in mind whenever you find yourself in a situation where you have nested arrays and need to work with them. And believe me, that happens more often than you think. And I believe that even in the course of this course, there is going to be another situation.